Hi students, this is Mr. Yang. Today we are going to continue to learn more about the basics of circles, and today's lesson is mainly focused on tangent lines. First, tangent line theorem. A line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Well, that sounds very mathematical. Let's kind of see what it means. It's basically saying if you have this tangent line, it's guaranteed that this point that the tangent line is meeting the circle with, if you connect it with a radius, this angle will be 90 degrees. Or vice versa, if you have a radius and then there's another line and they're actually forming this 90 degrees, then this line must be tangent to the circle. If this line is actually touching that point. So that's kind of what it is, and that's also what if and only if means. It means it needs to go both ways. And the one way to check about perpendicular is Pythagorean theorem, because we can actually draw this line here, and then that's guaranteed to actually be a right triangle. That's what we're going to do. So here's an example. If PT is the radius of circle P, is ST tangent to circle P? Well, it's basically asking if this is actually a 90 degree or not. Well, we can use Pythagorean theorem because we have this triangle right here. If Pythagorean theorem satisfies it, that means it is a right triangle. So all we need to do is set it up. 12 squared, 35 squared, and we're trying to see if it actually equals to 37 squared. 12 squared is 144, and 35 squared is 1225, and 37 squared is actually 1369. If you look at the left side, 1369, and the right side is 1369. That means yes, it does work. We were just checking, and now yes, it is tangent. That's example 1. Example 2, same idea. You can try to practice yourself. So the only difference is 2 is this part, so you do need to know what is this portion right here. That is 3, because that's a radius. And you're trying to check if this angle is a 90 degree or not. So let's have a look. 3 squared, 4 squared, that's the shorter side, and we're trying to see if it actually equals to the whole thing together, which is 5 squared. That's 9 plus 16 on the left side. The right side is 25, left side is 25, and it does equal to the right, which means yes, it is tangent. That's example 2. Next, example 3. This question is slightly more interesting, because you're told that is a tangent, which means you know this is a 90 degree. You also know this is a 90 degree. And it's asking you to find the length of AD. You can try to draw some lines to see if you can figure it out. Now, here's the thing. This side is 8, this side is 5, and this is basically a trapezoid because of these 90 degrees, and also these two lines are going to be parallel. So if you want to find out AD, you clearly need some kind of right triangle. Otherwise, there's no way. But if you connect this line, well, that's actually not a right triangle. If you connect this line, that's not a right triangle because you're breaking down that angle and that angle. So that means you can't connect that way. You can't. The only other way is to actually use the 90 degrees. To use 90 degree, we can actually make rectangles. So here's what we're going to do. We are actually going to draw a line right here to make it 90 degree. In that case, I already know this is going to be 20, and this little portion, because this is a rectangle, is going to be 5, because it's going to be the same as this radius. That makes the rest, which is this portion, a 3, because the whole thing is 8. If this little portion I just generated is a 5, the rest must be a 3. And now you can actually use Pythagorean theorem because this has got to be 90 degrees. So AD is actually going to be the square root of 20 squared plus 3 squared. Well, because 20 squared plus 3 squared equals the question mark square, or AD squared. Now you just need to type in your calculator, because this whole thing is square root of 409. And if you type in your calculator, that's going to give you 20.22. We're running 2 decimal places. That's example 3. Moving on, example 4. B is the point of tangency. Find the radius r of circle C. We're still going to need to use Pythagorean theorem. As soon as we know this is point tangency, that means this is 90 degrees. That means we can use the Pythagorean theorem. So it's going to be r squared plus 80 squared equals to, the hypotenuse is actually, this part is 50, this part is radius, so it's got to be together, 50 plus r being squared. This time we already know it's tangent, so we do know it's an actual right triangle, so we can already set it up. Now let's actually solve it. R squared plus 6400 equals to, something for you to remember, I've emphasized since the beginning of the school year, if you have a square, you gotta write it twice. And then do your distribution. That's going to give you 50r plus r squared plus 50r plus 2500. The whole thing now is r squared plus 6400, which is r squared plus 100r plus 2500. R squared will cancel. All you have left is subtract 2500 on both sides. 3900 equals 100r. That means my r is actually going to be a 39. Don't forget the unit, feet. That's example 4. Example 5 is the same idea. You can pause here and try that by yourself. Now, same thing. If that is tangent, this is 90 degrees. So we have 24 squared plus r squared equals 18 plus r squared. So it's going to be 576 plus r squared, which equals to 324 plus r squared plus 36r. Again, you gotta write it twice so you can distribute. I just automatically distributed already. R squared is gone, and we need to subtract 324 on both sides. That's going to give us 252 equals to 36r. Divide both sides by a 36. R is going to be a 7. That's example 5. Next, we have something called tangent segments theorem. Well, the previous one is just identifying, based on a tangent line, you have 90 degrees. This one, if you have a point outside, you can actually draw at least 2 tangent lines. So here's point S. You can send a tangent line right here and send another tangent line here. We already know these are going to be 90 degrees. We already know that. But here's something else. These 2 portions are actually going to be congruent, which in other words, if we are told they are tangent, then we also know SR is congruent to ST. If you would like to prove it, the basic idea is you can connect the S and the P, and then you see these 2 triangles. And because these are tangent lines guaranteed to be 90 degrees, and these are both the radius, and that is also a line that they share, so you can actually use the HL for triangle congruence to prove, because that is a leg that are the same and the hypotenuse that are the same. So this is tangent segment theorem, because we're actually comparing the little segments that are the same. Now let's have a look at some examples. Example 6. These 2 are tangent lines, so we know tangent segments are going to be the same. So 3x plus 4 equals 28. Subtract 4 on both sides, 3x equals 21. Divide both sides by a 3, x equals a 7. That's example 6. Example 7. The radius of circle Q is not equal to the radius of circle R. Is it true that PA and PB and PC are actually congruent if they are all tangents? That's something that's forgotten, that is not mentioned in the question. But PA and PB are both tangent segments, so they are the same, and PB and PC are both tangent segments for the second circle. They're also the same, so that it's guaranteed that they are all the same. That's example 7. Next, example 8. Same idea. These 2 things are same, these 2 portions. So 2x squared plus 5 equals 13. We just need to subtract both sides by a 5. There's nothing else. We just need to get the square by itself. So 2x squared equals 8. Divide both sides by a 2. X squared equals 4. Square root both sides. X is a 2. But it's actually asking for AC, which is going to be interesting to solve. Here's AC. Something that you may not notice is the question also said the radius of C is actually x. That means this part is x, which is 2. So if you want to find AC, that is going to be 13 squared plus 2 squared, which is basically 169 plus 4, which is 173. So it's square root of 173. Typing your calculator, that is going to give you 13.15. So that's AC. And that is example 8. Example 9, this is an interesting question that you can pause here to try by yourself for a bit. Now, these are tangent segments, and this little segment is given, so that's 8.4, which guarantees this part is also 8.4. But on that side, we also know the whole thing. The whole thing is 18.5. If that little portion is 8.4, that this little portion must be 10.1. And that is a tangent segment. That's another tangent segment from the same point, so this portion would also be 10.1. And if we keep moving along, if that whole thing is actually 22.1 and this little portion is 10.1, we can find out this portion is going to be 12. If that's 12, same point tangent segment, that is also 12. Now we actually have found every single part on the whole triangle. We can find the perimeter. The perimeter is going to be 12 plus 8.4 plus this side is 18.5. This other side is 22.1. And that is going to give us, that's 26.8, that's 38.8 plus 22.1. Final answer should be, that's 60.9. And that is example 9. That's everything for 6.1c. Thank you.